When heavy rain hits a city, millions of gallons of water have to find somewhere to go almost immediately. That is the problem cities are constantly fighting. In a forest, rain can soak into soil, collect in wetlands, or slowly make its way into streams. But in a city, rain hits rooftops, roads, sidewalks, parking lots, and concrete. These surfaces do not absorb much water, they move it fast. That is why a storm that might be manageable in a natural landscape can become dangerous in a city. The water has fewer places to soak in, so it runs across the surface, collects in low areas, fills streets, overwhelms drains, and can turn roads into rivers. So how do cities stop rain from flooding everything? The answer is not one system. It is a layered network of drains, pipes, basins, tunnels, pumps, levees, sensors, parks, wetlands, and maintenance crews, all working to control where the water goes. The first line of defense is the one most people see every day. Storm drains. Those metal grates along streets and curbs are not just random holes in the road. They are entry points into the city's stormwater system. When rain falls on streets, water flows toward curbs and gutters. From there, it enters storm drains and moves into underground pipes. Those pipes carry water away from roads, buildings, and low-lying areas. In simple terms, storm drains are the city's way of grabbing water before it spreads across the surface. But storm drains only work if the water can reach them. That is why block drains are such a big problem. Leaves, trash, mud, and debris can clog grates. When that happens, water backs up onto streets even if the underground system still has capacity. This is one reason maintenance matters. Clearing storm drains before and during storm season can prevent localized flooding. A city's flood system is not only giant tunnels and pumps. Sometimes it is a crew clearing leaves from a grate. Once water enters the drain, it moves through a pipe network. Some pipes are small and serve individual streets. Others are large enough for people to walk through. The system is designed to move stormwater toward rivers, channels, treatment systems, storage basins, or outfalls. But there is a catch. Pipes can only carry so much water at once. If rain falls faster than the system can move it, flooding can still happen. That is where storage becomes important. Cities do not always try to move all the water away immediately. Sometimes the smarter strategy is to hold it back. That is the job of detention and retention basins. These are areas designed to collect storm water during heavy rain. A detention basin temporarily holds water and releases it slowly after the storm. A retention basin may hold water more permanently, often as a pond. The idea is simple. If all the rain rushes into pipes and rivers at once, the system can be overwhelmed. But if some of that water is stored and released gradually, the peak flow is reduced. Think of it like slowing down a crowd leaving a stadium. If everyone rushes out at once, the exits jam. If the flow is controlled, the system handles it better. Stormwater works the same way. Some of the most interesting flood infrastructure is hidden underground. In dense cities, there may not be enough open land for large basins, so cities build storage below the surface. That can include underground tanks, tunnels, reservoirs, and deep stormwater shafts. During heavy rain, excess water is diverted into these spaces. Instead of flooding streets or overwhelming sewers, the water is temporarily stored underground. After the storm passes, the water can be released slowly, pumped out, or sent for treatment. This kind of infrastructure is expensive, but in crowded cities, underground space may be the only practical place to store stormwater. Tokyo's massive underground flood control system is one famous example. Other cities use deep tunnels to capture stormwater and combine sewer overflows. The concept is the same. When the surface system cannot handle all the water at once, the city needs hidden capacity. Now let's talk about pump stations. Gravity is useful, but it cannot solve everything. In some cities, water naturally flows downhill toward rivers or the ocean, but in flat or low-lying areas, water may not drain fast enough by gravity alone. That is where pump stations come in. A pump station uses mechanical pumps to move water from one place to another. It can lift stormwater out of low areas, push it through pipes, or move it over barriers. Pump stations are especially important in cities near coastlines, rivers, or below sea level areas. Without them, water can collect in places where gravity has nowhere to send it. During major storms, pump stations may run continuously. Operators monitor water levels, rainfall, equipment status, and power supply. Backup power matters too. A pump station is not very useful during a flood if it loses electricity. This is why flood control is tied to the power grid, emergency planning and maintenance. Then there are levees and flood walls. These are barriers designed to keep river water, storm surge or coastal flooding away from developed areas. A levee is usually an earthen embankment. A flood wall is often a concrete or steel structure. Both are meant to hold water back. They can protect neighborhoods, roads, industrial areas, and downtown districts, but they are not magic walls. They need inspection, maintenance, and careful design. If water rises higher than expected, overtops the barrier, or finds a weak point, flooding can still happen. This is why flood protection is never just about building one wall and forgetting it. It has to be monitored and maintained. Now, modern cities are also moving towards something that looks much softer but can be just as important. Green infrastructure. Instead of only using pipes and concrete, green infrastructure uses soil, plants, trees, and natural processes to manage stormwater. Rain gardens are one example. A rain garden is a planted low area that collects runoff from roofs, sidewalks, or streets. Water can temporarily pond there, then soak into the ground, or drain through an underdrain. Bioswales work in a similar way, often as planted channels along streets or parking lots. They slow water down, absorb some of it, and filter pollutants. Permeable pavement is another tool. Unlike normal pavement, it allows water to pass through into layers below. This reduces runoff and gives rain somewhere to go. Wetlands, parks, and restored stream corridors can also help by storing and slowing water. This is why some parks are more than recreation spaces. During dry weather, they may look like ordinary green areas. During storms, they may quietly act as flood control. Green infrastructure does not replace pipes and pumps everywhere, but it can reduce the amount of water entering the system in the first place. That matters because urban flooding often begins with too much runoff too quickly. Older cities face another challenge: combined sewer systems. In some places, stormwater and sewage flow through the same pipes. During dry weather, that wastewater goes to a treatment plant. But during heavy rain, stormwater can enter the same system so quickly that it overwhelms capacity. When that happens, combined sewer overflows may release excess water into rivers or other water bodies. These systems were often built long ago, before cities understood stormwater and pollution the way we do today. Fixing them can require storage tunnels, treatment upgrades, green infrastructure, and overflow controls. The goal is to reduce how often the system overflows and how much untreated water reaches the environment. This is one of the reasons flood prevention and water quality are connected. When rain moves through a city, it does not stay clean. It can pick up oil, trash, metals, fertilizers, bacteria, and other pollutants from streets and surfaces. So stormwater systems are not only about preventing flooded roads, they are also about protecting rivers, beaches, and drinking water sources. Technology is becoming a bigger part of flood prevention too. Cities use rain gauges, river sensors, weather radar, flood models, cameras, and control dashboards. These tools help operators see what is happening in real time. How much rain has fallen? How high is the river? Which pump stations are running? Which basins are filling? Which roads are flooding? This information helps cities respond faster. Some systems can adjust gates, pumps, or storage areas based on current conditions. Others help emergency teams warn residents, close roads, or prepare resources. Flood prevention is not only physical infrastructure, it is also data. But even with all these systems, city flooding is getting harder to manage. There are a few reasons. More pavement means more runoff. Aging pipes and drains may not be large enough for today's storms. Development can remove natural storage areas, and in many places, heavy rainfall is becoming more intense. Coastal cities also face sea level rise and storm surge, which can make it harder for stormwater to drain out. If the river or ocean is already high, water flowing from the city may have nowhere to go. This is why cities are rethinking flood design. Instead of only asking, how do we move water away? They are also asking, where can we safely store it, slow it, absorb it, or redirect it? That is the big shift. The best flood systems are layered. Storm drains capture water from streets. Pipes move it underground. Basins store it temporarily. Pump stations lift it where gravity cannot. Levees and floodwalls hold back rivers or storm surge. Green infrastructure absorbs and slows runoff. Sensors and forecasts help cities respond before conditions get worse. Maintenance keeps the whole system working. No single piece does everything. Flood prevention is a chain. And if one link fails, the others matter even more. The next time heavy rain hits your city, notice where the water goes. Watch it run along the curb. Watch it disappear into a storm drain. Look for low, grassy areas, ponds, channels, or planted strips along streets. Think about the pipes below the road, the pumps you cannot see, and the control rooms watching water levels rise. A city is constantly negotiating with rain, trying to move it, slow it, store it, absorb it, and keep it away from homes, roads, subways, and businesses. That is how cities stop rain from flooding everything. It is not one drain or one wall. It is a hidden system of engineering, nature, maintenance, and planning. And like many systems we rely on every day, the better it works, the easier it is to forget it exists. If you enjoyed this video, make sure to like and subscribe to Hidden Infrastructure of the World. Also, comment down below what hidden infrastructure you want to see next. See you in the next video.